Camp on everyone. So last thing we are doing is 2 block problems. Great. So let's start off with one. Let's see how much you remember this. Three kg, 2 kg. Let's say this time mu is 0.5, and let's say you're applying F is equal to 15 newtons. Find acceleration. Find acceleration, friction, and the maximum F. The ground is smooth. If blocks go together. And then, okay, let's do this first. Then I'll change the data a bit. The main idea is this: Q cannot take F max unless you prove they're slipping. That's it. The biggest blunder people do, they draw an FPD, they put F max directly. The moment you do that, you're gone. Sometimes you'll be lucky, but every time you won't be. And that told you the process last time. Start with an assumption they're going together, find the F required. If it is less, then great, problem is over. If it is more, that is also fine, because now you know friction is maximum. Draw a new FBD and solve. Try. I'll give 3 minutes. There are 2 parts for the question. And what is the maximum force you can apply so that the blocks go together? Anyone not clear with the diagram of the question, please ask. Acceleration is 2 and 3. So you're saying the slipping then? Should you take F max? So did you prove that? Arya?
Yes, sir.
You proved they're slipping?
Yes.
Okay, let's see. But I think you are wrong. Most of them got different. One more minute, then I'll show you the answers. Ansh, you got something. Ishana, yeah. Get me all three. You have to tell me all three, then I'll see. Ishana got something. Might be right. You have to give me three. You have to give me the acceleration of the system. You have to give me the friction. You have to give me the F max. Give me all three. Try. I'll give you a minute more. Roja got something else. Acceleration you got same. I don't know the answer even. I have to check. So I'll show you. Let's see. Arush, that looks really weird. Niharika, that's only the first part. Right? Get me all. Let's see. That might be right, Ahana. Step one. Assume all are going together. You see a 2 block or a 3 block problem. This is how you start. If you write an FBD input, Fmax, slap yourself. So assume both go together. So F is equal to 15 newtons and acceleration, since both are going together and the ground is smooth, acceleration is 15 by 5 is 3 meter per second square. Perfect. Choose any one block. I'll take the 2 kg block. You can choose 3 kg also. The reason I like 2 kg is because there's only one force. That is F. Never write F max. F is equal to 2 into A, which is 6. Fair enough. But what is maximum? Remember, the friction between them will depend only due to the normal between this 2 kg here. This is 20 mu into n, that is 10 newtons. So I can give you 10, but you're asking only for 6. This is your F required. So F required is less than F max. Therefore, assumption is right. First part is done. Both the blocks are going together, 3 meter per second square. And the friction is 6 newtons, not 10. Have a look at the steps. Now, the second part of the question, you said maximum F if blocks go together. That word itself gives you something. Maximum F, matlab the blocks are on the verge of slipping and they're going together. Means both are happening. For maximum F, both are going together. 3 kg, 2 kg, acceleration F is equal to 5A. Choose any one block. Again, I'll choose the 2 kg block. Now, since they're on the verge of slipping, blocks are about to slip. That is the meaning of maximum force. Little more and the blocks would have gone. This is the acceleration. This is 10. So A is equal to 5 meter per second square. Therefore, F max 5A is 25 newtons. If you exceed 25 newtons, they'll start slipping. Anything less than 25, they'll go together. Clear? This is what we did last time. I just changed the values and the force cut. I kept it on the lower block. Up to this level, you'll be able to handle all mains level questions and bits level questions. Let's see what will happen if you just bump up the level a bit. Clear? Next one. Same question. Let's do one thing, one more. Same question. Let me change it like this. 2 kg block. I will keep the block same, so that it will be easy for you to see what is happening, what are changing. This F is equal to 15. This mu S is 0.5. Mu K is 0.2. अभी ग्राउंड का भी फ्रिक्शन है. Mu S is 0.2 and mu K is 0.1. Now can you repeat the question? Find acceleration of the blocks. Frictions. So there are two frictions now, ground ka friction and the upar ka friction. And maximum F if they go together. There. Now we are using point mu case also. Let's get this. Now there's a friction on the ground. First you need to check something. What do you need to check? What is the maximum friction on the ground? 0.2 into 50. 10 newtons, right? And how much you're applying? 15. That means your friction is greater than the ground, so block will move. And just to give an example, listen. Agar socho ground mein mu s is 0.5, you know what is the answer? That would be the best question. The maximum friction on the ground will be 25. You're applying 15. System won't move only. Everything is at rest. So you need to check whether can you overcome the friction on the ground first. If you can't break the friction on the ground, you won't move in the first place. Try. Give it a try. Think about it. It's okay if you get a wrong answer. Try 2 minutes. I'll show you. Mu k comes into picture only if you're sure there is a slipping. Okay. Let's see. Try 1 more minute, then I'll show you the whole thing. I don't know the answer, so I can't tell whether it's right or wrong. I just made up the numbers. Okay, let's see. First thing you need to check now. See, the problem here is in the previous problem, right? Think of like this. What are the possibilities? Meaning, what are all different situations you can have in this problem? Tell me. I'll tell you what I mean. Case one, can this be ever be at rest? In this problem, 18th one, can this system be at rest? If you apply force? No, right? Why? Ground is smooth, you have to move. Okay. One, they can go together or they can slip and move. Bus, is there any other possibility? There are only two possibilities. Either you both go together or you both slip and go together, slip and go, isn't it? But now in this problem, what is the possibility? Number one, you can be at rest. Number two, you can go together. Number three, you can move and you can slip. There are three possibilities that can happen here. So that is how you start. Okay, what all things can happen here? So first you need to check the first possibility. Are these things moving or at rest? So first thing you need to check the maximum friction on the ground is mu_s and n ground. The normal action on the ground is 50 newtons. 0.2 into 50, this is 10. So since F is greater than F max ground, blocks move. There, we proved the system is moving. So first possibility is gone. Great. Now, then what to do? Start with the same story. Assume both are going together. That's what, that is the best thing. When you learn a process, right? Every problem, you need not do everything from scratch. This is like writing a programming, a language. If you're writing a code or something for a program, you have everything in modules. Every time you want to create a new program, there's no need to write everything from scratch. You can directly use this module and keep it here. You can use this module and keep it here. So for example, tomorrow when you're designing a website, you don't write the entire code from scratch. You will find certain modules which you can just directly implement and you can make a website in 2 hours, a fully functional website. So the idea is the same thing. Like if you see in these problems, right, everything, step one is what? Choose your diagram and draw an FBD. But remember, don't we have a steps for how to draw an FBD? You got so used to it, you don't remember. You're getting it? So inside that steps, there is one more thing called drawing an FBD ka steps. Finding the direction ke liye of friction, there is a step, remember? Assume there's no friction and everything. So if you actually, that's what I'm saying, be conscious when you're doing a problem. Some of you have this issue, you do the problem, you get the answer, but you're not conscious of what steps you're using. So what happens now? When you get stuck with a problem, you won't understand, how did you proceed and how did you think about it? So when you're solving a problem and getting an answer ke baad, be conscious. How did I proceed with this? What did I use exactly? This is a little slow process, but trust me, this is what will make you strong. Most people are obsessed about, मैंने 1 hour में 20 questions solve कर लिया. Fine, great, you did 20 questions, but after that, what? And that is a reason. Ever happened to you? You go to an exam, you see a question and you feel like, yeah, I have seen this question before, but I don't know what to do. The reason that happens is because you are just obsessed about getting an answer. You didn't actually calm down and think like, okay, this is what made me think this way. And this is important, right? Not only about physics or JEE exam. When you go ahead in life, if you can't think this way, this is what will make you different from others. You will find people who are more smarter than you. You will find people, geniuses. People will work hard. But, you can beat them by this way. If you are a slow learner like me, this is the way you can beat them. You take a process, you compartmentalize it, and you be clear what you're doing and why you're doing. You're getting it? So it is like IQ, hard work, there are multiple things, your process, how you learn, there are different ways of learning. It's okay if you're not top in one of them. But even if you're, second or third place in 3-4 things, you're a different person. You're getting it? You need not be top in one thing. So understand. So when you're solving a problem, really try to understand, like, why am I doing this way? Ask yourself. You need to talk to yourself every time. Most people don't do this. You guys don't talk to yourself. You talk to your friends more than you talk to, yourself. That's the reason we know more about our friends than ourselves. I'll ask you a simple question. Say, I'm sure everyone has a best friend or a close friend here, right? Right. So Tell me 3 good things about your best friend. Just think about it. 3 good things. Maybe they're very generous, they're very good, they're helpful, something, whatever it is. Done? Say 3 good things about yourself. Three good things about yourself. It was more difficult, right? Let's do the other way around. Say 3 bad things about yourself. Done? Say 3 bad things about your best friend. Did you realize something? We see more good in others, we see more bad in ourselves. When I said say good things about yourself, you are struggling. But same thing, good thing about your friend, tuck, 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 you say. It comes out very fast. Bad things, it comes out very fast. I'm very moody, I'm angry, I'm short tempered, I'm like that, I'm like this. Tell 3 bad things about your friend. Ha, she is angry, but kabhi she's fine. Matlab, you will try to compensate to say like, she's not bad or he is not bad. But same thing about you, you don't have any hesitation. You will just say, I'm an idiot. Matlab, the kind of compassion we have for others, right? We don't have it for ourselves. That's the problem. Just imagine, right? You wrote an exam, your best friend wrote an exam, and she scored 60 out of 100, or he scored 60 out of 100, and comes crying to you, अरे यार मैंने बहुत मेहनत किया last 2 weeks से मेरा score सिर्फ 60 आया. And you ask them like, यार last time कितना आया? Last time तो मेरा 44 था. And what will you tell them? Tell me. Will you tell them, अरे bullshit यार, you're good for nothing, right? You got only 60, इतना improvement है, you're useless. Will you say this to your friend? What will you say? अरे यार improvement तो हुआ ना, it takes time. Why are you in a hurry? This is for 2 years. You worked hard for 1 to 1 months and you did improvement. So this will take time. Take it as a journey. Enjoy. You will tell every good thing, to say them, yeah, it is fine. You are going in the right direction. But the same thing when it comes to yourself, you will curse yourself. You will blame yourself. You will make your life hell out of it. I'm good for nothing. मैं कुछ नहीं कर रहा हूँ. मैं ये हूँ वो है ये. Why? मतलब, why do we have so much compassion for others? We understand and we do this, but when it suddenly comes to us, we are very cruel to ourselves. Some of you have this problem. Some of you have this problem. I'm telling you, you are more important. In your entire life, no one is more important than yourself. So have some compassion for that person in the mirror. When he scores or she scores less, understand why it is happening. Try to work on that. Did you score less because you didn't work hard? Maybe that is the reason. Maybe you really kept effort but it didn't work out. Maybe the process is wrong. Maybe you didn't think that way. So see, whatever I'm telling you, all this is how you think. If you don't think, you'll have a problem. You have to be compassionate with yourself. You will improve. If you keep beating yourself for every small damn thing, you're hurting yourself. Trust me one thing. Your friend comes and tells you, "Na, I scored 40, I scored 60." You try to shout on them. Second time, they won't come and tell you. Isn't it? You are no different, right? That the same thing is happening with you. You score less, you start blaming yourself for every damn thing. You really worked hard, na? That is fine. You didn't work hard, then you should say, yeah, I didn't work hard. Blame yourself and go and work. So if you're doing everything right, have some patience. It takes time. And again, don't compare with others. Maybe someone is really very capable and very intelligent. Usko aayega 100 out of 100. We can't do anything about that. You scored last time 40, na? This time score 50. You scored 50, na? Score 55. You score 55, na? Score 60. 60 no ऊपर नहीं जा रहा है ना? Score maintain 60. Sir, but the other person got 100. Arre, let him die, na? Re. That's not your problem. मैं seriously बोल रहा हूँ. Don't make your life miserable. This is your own journey. You take it at your level. Tell me one thing. If you're some guy in the class got IIT Bombay first rank आ गया and तुझे IIT Bombay में the branch what you got आ गया कुछ, are you not satisfied? Why do we need to bother about what the other guy is doing? Let him go to hell. As if IIT is the only thing in life. ये नहीं किया तो कुछ है ही नहीं है life में. If not this bullshit, you'll do something else. There are 100,000 ways to to succeed in life. IIT is just one way. And I'm seriously telling you. I have been there, I have seen that. So focus on this thing, focus on a subject, you keep improving, keep learning. Every time you do a question, after getting the answer, ask yourself, what made me think this way? It's okay. Sometimes you'll figure out, sometimes you don't figure out. That is totally fine. So focus more on learning. Trust me, score is a byproduct. It will come. Anyways, getting back to this. So same thing. So this is the new part that we learned now. We have to check for the ground ka friction. Again, we start the same story. Assume both go together. This is at least this is how I like to teach. I like to teach in modules, like this part, this part, this part. So whenever something changes, I will say, let's use that part, let's use this part. Meaning this is an analogy from programming. This is what you do exactly in programming. And this helps you because this will help you to remember better. You can connect any chapter to any chapter. You can't do this in maths or chemistry. So don't think every chapter is different. So 2 kg, 3 kg. This F is equal to 15 and acceleration. And look at every question how I do. I draw an FBD, I check and everything. Now, since it is slipping, the friction, ground mein the friction is maximum. This is F kinetic. So this is the catch, everyone. If it is slipping, you have to use mu k n. And that is maximum because it is slipping. I'll write Fk. The mu k is 0.1 and n on the ground is 50. It is 5. So did you observe one thing? F maximum ye static tha. If you want to move, you have to give more than static. But if you move, friction suddenly drops to kinetic. Is that clear? So from here we get F minus Fk is equal to 5a. That's 15 minus 5 is equal to 5a. We get acceleration is 2 meter per second square. Perfect. Take any one block. I will again take the 2 kg block. This friction is F. This is acceleration. F is equal to 2 into 4 newtons. But what is F max? F max is 0.5 into 20. That is 10. Perfect. The F required is less than F max. My assumption is right. They're going together. Done. Question ho gaya. So both are going ahead with 2 meter per second square. Friction between the blocks, I will just write F blocks, is 4 newtons, whereas the friction on the ground is 5 newtons. It is slipping. Is this clear, everyone? Anyone not clear with the steps, please ask. I hope this is making sense. We did nothing new except for the fact we have to check whether it is moving or not on the ground. Then for the second part, when you say it is going with F max, blocks are about to slip. Now you have to be careful. Blocks are about to slip between them. So this guy, three kg, 2 kg. This would be acceleration. This is Fk, which is 5. F minus 5 is equal to 5a. Take the 2 kg block. Remember, slipping still didn't happen. So this is F static max. If the block had been slipping, you would have got F kinetic. This is 10. So A is equal to 5. Take this and put it here. F minus 5 is equal to 25. F is equal to 30 newtons. So 30 newtons is the maximum. Anything more than this, the blocks also will start slipping between them. You should use kinetic only after the slipping starts. If you're on the verge of slipping, it is still static maximum. I hope you're getting the difference between Fk and mu F static now. Please check. Ask me if there's any doubt on this. So if you're sure it is slipping, so it is like this. Solve the problem taking static. Once you prove it is slipping, then friction ka place mein start putting kinetic. So story is the same. You have to prove they're slipping or not. That story will not change. And that was the whole point of the chapter. You have to prove whether it is slipping or not. Clear? Got this? Any doubts on this? Please ask. Nikhil, clear with this? Ojas, Vignajit, Sharman, clear? Adi, Ahana, Daksha, got this? Clear? Next one, let's bump it up. Three kg, 2 kg. The ground is smooth. This is mu s. Let's say 0.3. You are applying F equal to time. T is time. So you are applying a force which is changing with time. Plot acceleration versus time graphs. Now this is a pretty good question. Reason, see, when you increase in the time, you will get all possibilities, isn't it? But sometime they won't slip, sometime they'll slip. But literally you're covering all the forces from 0 to infinity. Unlike the previous problem where you're solving for single force, when you give F is equal to time, you're solving for everything. Take a minute, think about it, then I'll show you. Plot AT graph for both the blocks. Try, take 2 minutes, it's fine, give it a fight. Let's see, and then we will see how to do this. I'll show you one model. You need to see this. If I didn't give mu k, that means you use mu s, mu k, both are same. We'll slowly introduce, and we'll introduce mu k and all that stuff. Anyone didn't get the question, please ask. Yeah, you have to draw AT graph for both the blocks. Let me give you an idea for this. Let me show you with the time. Listen. Same story. Assume both are going together. That is the best thing about a process. If you see entire NLM, we did more than 30-40 problems with the process only. So the only difference is now you'll get A in terms of time. So this is your acceleration. I'll just put here A. So we get F is equal to 5A. So acceleration is equal to T by 5. So acceleration is not constant, it is changing with time. Then choose any one block. I will choose the 2 kg block. Friction is forward. This is your acceleration. So F is equal to 2A. F is equal to 2T by 5. Now understand the meaning of this. This is the required friction. So friction is saying at T is equal to 1 second, you need to give me 2 by 5. At T is equal to 5 seconds, you need to give me 2 newtons. At T is equal to 10 seconds, you have to give me 4 newtons. You're getting what friction is saying? As time increases, my requirement also increases. I need more and more. So this is the required friction with time. I hope you're getting what is the meaning of that word now. 2t by 5 is saying, friction is saying, at a given time t, give me this much friction. But how much can I give? But this should be less than equal to f max. I can't give you more than this. And that would be 2t by 5 is less than equal to mu into n. That is 0.3 into 20. That is t is less than equal to 15 seconds. Right? So friction is saying up to 15 seconds, I can make them go together. So the meaning of this is up to t is equal to 15 seconds, blocks go together. So for t greater than 15, what happens then? For t greater than 15, f is maximum, they slip. Therefore, f is maximum. Perfect. So for t greater than 15, draw new FBDs again. So this friction is F max, which is 0.3 into 26 newtons. 2 kg. This acceleration is A1. A1 is 3 meter per second square. So 2 kg acceleration became constant. Whereas the 3 kg guy, F is equal to T. This is F max equal to 6. This is A2. T minus 6 is equal to 3 A2. A2 will be T by 3 minus 2 meter per second square. This acceleration is continuously increasing. So if I try to plot a graph for this, I'll turn the page. So AT graph. Initially, what was the acceleration? So we have two parts here. For t less than 15, both the blocks A1 and A2 are going with t by 5. That was the acceleration when both are going together. This is looking like y is equal to mx, where m is the slope, which is 1 by 5, and that is tan theta. That means initially the graph is a line passing through origin up to 15 seconds. And this angle is tan inverse 1 by 5. I will show both the lines with different colors. They will look identical. For t greater than 15, the acceleration A1 became 3, whereas A2 became t by 3 minus 2. So this became constant red line. So this is your A1. This is the 2 kg block. And this value is 3 meter per second square. That became constant. But this guy, this looks like y is equal to mx plus c. And if you look at the slope now, slope has become 1 by 3. That means this has become more steeper. And this angle now is tan inverse 1 by 3. And this is the acceleration of A2, the 3 kg block. So after 15 seconds, both the graphs will diverge. The 2 kg became constant, but the 3 kg started going up. And they're straight lines. Is this graph making sense, everyone? First, have a look at this page. Please ask me any doubts on this page. Step 1, we start with both are going together. Find the acceleration in terms of time. Find the friction in terms of time. Now we get everything in terms of time. So friction is saying, boss, you give me 2t by 5. At a given time t, you give me this much. I'll make sure your assumption is right. What is my assumption? Both are going together. But how much can I give maximum? I can give you maximum of 6. So up to 15 seconds, friction is fine with it. But after 15, they'll slip. So what to do? After 15, draw the new FBDs because they're slipping. So you find the accelerations because before 15 and after 15. Clear? Once you got this, it's max. Physics got over here. The graph is simply max. And if you see all are straight lines only, y is equal to mx plus c. So the line will diverge. The line initially slope is 1 by 5, and the slope is 1 by 3. So the 3 kg block will, obviously, if you think about it, initially friction was also increasing. So 3 kg was not able to accelerate. But when the friction became constant and force is increasing, now 3 kg will rise at a faster rate. Is this clear, everyone? Clear? Let's see one more like this. Understood how to do with time now? Let's bump up the level. Same blocks, we will keep the block same 2 kg, 3 kg. Let's say mu s is 0.2, mu k is 0.1, mu s is 0.3, mu k is 0.1, and let's say f is equal to t. Plot 80 graphs for 2 kg, 3 kg. Try, I'll get 3-4 minutes. You can handle this 2 block problems, you are good. Try, take 3-4 minutes, let's figure it out. Give it a try, it's okay if you don't get an answer. Just give it a try, get some water and come. Hope you remember, there are 3 cases here. For some time, system won't move. For some time, they'll go together. And after that, they will slip. So there will be 3 possibilities. Try. I'll give you 2 more minutes. It's a worthy question. Try, Arush, give it a try. Show you. Give you one more minute. Now we're just done. You got something? Okay, let's see. Great. Let's see. First thing, what is the maximum friction on the ground? Listen carefully. This is a mess. So F static on the ground max is 0.2 into total normal reaction 50 is 10 newtons. Meaning up to 10 seconds no one moves. To T is equal to 10 seconds. System is at rest. That is the first part. You don't have enough force to break the friction on the ground. Then, second part, for T greater than 10 seconds, assume both the blocks are going together. Story is the same. Now we want to find up to what time they'll go together. Then F is equal to T. This is acceleration. Now because it is slipping, Fk kinetic on the ground suddenly becomes 0.1 into 50. This is 5. So T minus 5 is equal to 5a. So acceleration is T by 5 minus 1. Perfect. Now take any one block. I'll choose the upper block. Always try to choose the block, where there are less forces. 3 kg there are 2 forces. That's the reason I don't like to take the 3 kg. 2 kg there's only one force, makes life easy. So this guy is F and this is acceleration. Should I just call them F1, F2? Okay, you understand. I'll put it as F. So this will be F is equal to 2a. And then 2a is how much? And this should be less than equal to F max. How much is that? That is 0.3. This is static. F static max. How much is this? This guy is 0.3 into 20 is 6. So we have 2 into T by 5 minus 1 is less than equal to 6. So we get T must be less than equal to 3 plus 4, 20 seconds. There. So up to 20 seconds they're going together. After 20 they'll slip. Have a look at till here. Then for T greater than 20, blocks slip. Then if the block slip, then you draw a new free body diagram. This is 2 kg. This is F kinetic, which is 0.1 into 20. That is 2, and acceleration. So A1 is equal to 1. This guy became constant. If I take 3 kg, this is F is equal to T, and this is Fk is equal to 2. This is A2. This is T minus 2 is equal to 3A2. This is T by 3 minus 2 by 3. Got the accelerations? Now, if you look at the accelerations, A1, I'll write down here. So for the 2 kg block, this is the acceleration. Initially, it is 0 for T less than 10 seconds. Be careful now. There's something is going to happen now. And for between T 10 to 20,
Sir,
acceleration is T by 5 minus 1. Right.
sir, why didn't we take the friction on the ground?
Why didn't I take the friction on the ground? You're right. I forgot. F ground is also 5. You're right. I forgot. That would be T minus 7 is 3A2. And then acceleration is 1 for T greater than 20. If you observe, I didn't put equality signs. Okay. Then maybe I should just draw next page. That is for 2 kg. Acceleration for 3 kg, 0 for T less than 10, T by 5 minus 1 for T between 20 and 10. They were going together. And then it is T by 3 minus 7 by 3 for T greater than 20. Now see the graph. So when you plot AT graph, first we'll draw for 2 kg guy. I'll use red line. So it is touching 0 till 10 seconds. Then see what happens. If I put T is equal to 10 here, what do I get? If I put T is equal to 10 here, exactly this acceleration becomes 2 meter per second, isn't it? 10 by 5 minus 1 is 1 meter per second square. Meaning the value, right, is not starting from 0. It jumps. There is a discontinuity. You're getting it? Because the friction value suddenly changed, right? The block will suddenly accelerate. There's a jump. Look at here. When T is equal to 10, you got 0. T is equal to 10, you're getting 1. So it is a discontinuity there. So you have to be careful here. So T10 plus, it is 1. T10 minus A is 0. So there's a jump there. So you can't put an equal to sign. Then this is T by 5 minus 1. It's a line like this. This will go till 20 seconds. This line ka angle, if I take it as theta 1, tan theta 1 is 1 by 5. And then something more happens. See, this value is 1. If you put T is equal to 20 here, you get 20 by 5, that is 3. But 20 plus the value will suddenly drop to 1. The graph becomes like this. You're getting how is the graph? There is a discontinuity there. So initially 0, then it increases till 3, and then suddenly it drops back to 1. Please have a look at this thing. Once you got the axis, this is pure max now. What we're doing on this page is max. Now, can you do that for 3 kg now? I'll give you a minute. There, I gave you the equations here. Can you do this for 3 kg now? That's it. What makes this problem painful, right, is not actually the physics part, but the graph part. There's a discontinuities in the graph. So when you get a question like this, right, think of like this. Whenever there is a mu k, you'll get, if there are 2 surfaces and 2 mu k's, you'll get 2 discontinuities. Every time the friction value suddenly changes, the graph becomes discontinuous. So when the ground started slipping, you had a discontinuous graph. When the block started slipping, again, you got a discontinuous graph. Any doubts on this thing, please ask. You guys should definitely try all these things we did today again, these graphs and everything. Did you draw? First thing, see, I'll draw with a green line. This is the 2 kg guy. So initially it is 0, so great. Then again discontinued, it will go together here. So till here everything is fine. Now look at the value here. If I keep t is equal to 20 here, if I keep t is equal to 20 plus the acceleration 3 would be 20 by 3 minus 7 by 3, 20 minus 7, 13 by 3. That is almost 4.33. Meaning from 3, it suddenly jumped to here. 13 by 3. And then it became steeper also. This angle is theta 2. Tan theta 2 is 1 by 3. This is the acceleration of 3 kg block. There'll be two discontinuities. So that's the main catch there. Whenever there is a kinetic friction, there'll be discontinuity because the value suddenly changes. Acceleration will suddenly come. Is this clear, everyone? Let's see one more like this. I got 20 minus 20 plus matlab only it is undefined. It is a point. Clear? That's why we call it discontinuous function. Now I'll give you one more like this. Now you guys try. Now, technically, 3 block problems that are not in the.
Sir, 2 minutes. So just a minute, sir. The previous page. Yeah, so just a minute.
What were you doing, God? I gave you so much time to do it. Meaning when I explain, you don't listen, you do something else. That is a problem. Suno na, Ansh, when I'm explaining, see, I'm giving you time na. ऐसा नहीं मैं time नहीं दे रहा. At least when I'm explaining, तो please listen.
ठीक है, sir. Thank you.
Mm, we'll do one thing, but we'll keep the ground smooth. I kept two forces. एक काम करते हैं. Let's make it 3t. इसका भी डाल देते हैं ना. Where to leave it? F2 is equal to t. I kept the ground smooth. Plot 80 graph. You couldn't the ground also you can keep US mu. You got the idea. That will be same thing. Try. Got 2-3 minutes. 2 block problems are important. They are specifically mentioned in the portion 2 block problems. 3 blocks are not in the portion, but we will see 1-2 models just in case. Try. In this case, luckily, that first possibility is not there. They'll be at rest. They will move. Got something? Should I show you? Take a minute more. Once I show you, you can verify your answer. It's important you do something. It's okay when you get a wrong answer. Because when you get something wrong and when I show you, you will realize like, oh, this is what I should have done. That helps you in understanding. But if you just keep staring and waiting for my solution, it won't help. Try. Take a minute more. Let's see. Step 1, assume both are going together. There is no need to check because ground mein there is no friction. They will have to move. If there is a friction on the ground, I would have checked. Let the acceleration be A. F1 minus F2 is equal to 2A. 5A. So we get acceleration is equal to 2t by 5. Perfect. Take any one block. Now you don't have an option. Both have forces. I will take the 2 kg block as usual. This is F1. This is friction. This is 2 kg and this is the acceleration. So T minus F is equal to 2A. So friction will be T minus 2A, that is 4T by 5, which is T by 5. This must be less than equal to 0.5 into 20. That is 10.
Sir,
So
Sir, F1 will be 3T, no?
3T now. 3T था वो. Then कितना था ये? 5 3 15 minus 4 shit है number था bad. 11T by 5. This guy must be less than equal to 0.5 into 20. So we got T less than equal to 50 by 11. So up to 50 by 11, they'll go together. Clear? Then, so for t greater than 50 by 11, block slip. Now, if you're slipping, then we draw FBD separately. F1 is 3t, but be careful, this friction becomes F kinetic now. That is 0.1 into 2 newtons. And this is acceleration A1. So A1 would be 3t minus 2 by 2. 3 by 2t minus 1. So this guy, Fk will be 2 backward, 3 kg. This F2 will be t. And this would be acceleration backward. So A2 will be t minus 2 by 3. But be careful, the direction has changed. So it's a minus sign आएगा. Ground में friction नहीं है. It's got these values. Check out the values. Then, so let's put the values there. So A2 kg, the first they're going together with 2t by 5. For t less than 50 by 11. For t greater than 50 by 11, the 2 kg ka acceleration became 3 by 2t minus 1. 3 kg is also going with 2t by 5 for t less than 50 by 11. And this guy became t minus 2 by 3. Why am I getting a weird feeling here? Fifty by 11 is how much? Around 4 point something, right? This guy increased. Are my calculations right, or did I goof up somewhere? Okay, that friction is 0.5, na? Makes sense. Then this guy would be minus of t minus 2 by 3. There. Now let's plot the graph. So first the 2 kg, it will go like this. Let this be theta 1. This is still 50 by 11. If you look at the value there, yeah, that number is only messed up. Okay. You get some value here. Now if you put 50 by 11 here, 3 by 2 into 50 by 11 minus 1, 150 minus 22 by 22, 128 by 22, 64 by 11. The value will suddenly jump here to some 64 by 11. Initially, it is 100, 2t by 5 into 50 by 11, 5, 10. It was 20 by 11. There's a huge jump. And then this becomes steep. This guy is theta 2. So tan theta 1 is 2 by 5. Tan theta 2 is 3 by 2. This is your 2 kg. 3 kg is interesting. It goes like this. And then if I put 50 by 11 here, 50 by 11 minus 2 by 3, 11 to 22, 28 by 33. This value suddenly drops to negative because it's going backward. It becomes minus 28 by 33, 51, 20, yeah, 28 by 33. And then this guy becomes like this. This is angle theta 3. And that is tan theta 3 is minus 1 by 3. This an acceleration is negative, no? It goes downward. This would be the 3 kg block acceleration. Clear? Like I said, this is the proper physics part. This is complete math. Once you got the equations, it is about putting the lines. Actually, theta 3 would be this angle. Because it's an obtuse angle. Clear? That this is how you handle two blocks. Any doubts on these steps, please ask me. Nothing changes, the process is the same. Assume they go together, find the F required, and then see when it slips. The moment it slips, put the kinetic friction, draw the new FBDs, and so the story is the same. It just keeps repeating. Next one. Next one. Two kg, 3 kg, 5 kg, 3 blocks. 3 blocks will keep it simple. Like I said, it's out of portion, but the idea is the same. This is smooth. Let's say F is equal to T. Let's say this friction mu is 0.5. This friction mu is 0.2. Plot AT graph for all the 3 blocks. Take a minute, give it a try, then I'll show you. Then I'll give you one more like this. Wait, let's do one thing. Let's make this F is equal to T. I'm changing it. Wait. I have to change the values because it'll become too easy. ऊपर का 0.1 कर लेना. That would be it. That should work. Let's see. In 3 blocks now, the most messed up is when you keep F is equal to T in the middle block. But first, let's do this. That I'll give you next. Try it for a minute or two. I'll show you how to do one. Let's let me show you one. So first thing, the same story. Assume all are going together. So let this go with acceleration A. Listen carefully. There's a one catch in when you have three block terms. Assume all go together. Because the problem is every friction, right, is only bothered about its own surfaces. It doesn't care what the other guy is doing. So we get acceleration is equal to T by 10. So let's take any one block. Let's take the 2 kg block. On 2 kg block, let this friction be F1, and this is acceleration. We get F1 is equal to 2a. This must be less than equal to 0.1 into 20. So this is 2t by 10 is less than equal to 10. T is less than equal to 10 seconds. So friction is saying up to 10 seconds, I can keep the 2 kg block without slipping. Now take the 3 kg block. This would be F1. This would be F2, right? Or I can take the 5 kg block. It doesn't matter. 5 kg looks more safe. I don't want to deal with two frictions in the same FPT. F is equal to T, and this is definitely F2. This is acceleration again. So this is one possibility. This is the second thing you have to do. And then T minus F2 is equal to 5a. So we get F2 is equal to T by 2. And this should be less than equal to 0.2 into 50. Then this will give me T is equal to 20 seconds. Just give me a minute, guys. Some delivery guys come. Yeah, let's see. Then, now there's a problem here. Who is right? The 2 kg is saying, give me 10 seconds, I won't slip. And this guy is saying, up to 20 seconds, I won't slip. So you take the least time. You're getting it? So this is wrong. We take the least time. Understand why? We calculated F2 under the assumption no one slipped, isn't it? We calculated F2 under the assumption all were going together. Means you thought F1 was still safe, 2 kg was not slipping, and then you calculated for F2, isn't it? Are you getting the point? Tell me one thing. Once you cross 10 seconds, is this formula valid? This is not valid only, right? So how can you use that A is equal to T by 10 here then? Are you getting the point? The reason you calculated A is equal to T by 10 was under the assumption all three were going together. But at 10th second, 2 kg slipped. Matlab the 3 kg ka 5 kg, these equations are wrong. I hope you're getting it. So under assumption, all were going together. So F2 ka calculations are gone. But at T is equal to 10 seconds, 2 kg slipped. Therefore, case B is wrong. So this you have to calculate. Option nahi hai, but this is wrong. This is right. Clear with this? So that means the first time the slipping happened is at 10 seconds. All clear with this? So the question will split now again. So up to 10 seconds, all are going together. We proved it. For T less than 10, all go together. Now for T greater than 10, 2 kg slips. So draw the 2 kg FBD separately. 2 kg, this will be F1 max, which is 2 newtons. So this is the acceleration of 2 kg block. So acceleration of 2 kg block is 1 meter per second square. Perfect. What about the other two guys? 3 kg and 5 kg are like this. So this is F is equal to T, and this has become F1 max, which is equal to 2. Now this has become a 2-block problem. Assume 3 and 5 kg go together. This is how you solve. You make a 3-block into a 2-block problem. Now we don't know when these two are slipping together. यहाँ पे kinetic नहीं है रे, all are static only, so problem नहीं आएगा. Equality sign will not come when there is a kinetic friction, when the value changes. यहाँ पे I didn't give mu k. Already this is messed up enough. If you bring mu k, that will be like more. So again start with the story. Both are going together. So T minus 2 is equal to 8a. So we get acceleration is equal to T by 8 minus 1 by 4. Choose any one block. I will take the 3 kg guy. This will be F2 and this will be 2 and this is the acceleration. So F2 minus 2 is equal to 3a. We get F2 is equal to 2 plus 3t by 8 minus 3 by 4. This is less than equal to F2 ka maximum value is how much? 0.2 into 50. So this is 3t by 8 plus 5 by 4 is 10. Yeah, why the numbers are so bad. Multiply 8 on both sides. 3t plus 10 is less than equal to 80. So t is less than equal to 70 by 3. This, if you see, is roughly 23.33 seconds. Did you notice something? Previously, how much did you got? You got 20 seconds, right? But in reality, when was 3 kg and 5 kg slipping? 23.33. Because this 20 you got under the assumption 2 kg was still there. But the moment 2 kg started slipping, right, this whole thing went wrong. So the question is then when did 3 kg and 5 kg slipped? Now, so for t greater than 70 by 3, 3 kg and 5 kg slipped. Then you draw them separate FBDs. For 3 kg, this will be F2 max, which is 10. This is 2. This is A 3 kg. So acceleration of 3 kg will be 10 minus 2, 8 by 3. And this guy, F is equal to T. This is 5 kg. This is F2 max equal to 10. So acceleration of 5 kg will be T minus 10 by 5. Now, if you try to plot the graph, so acceleration of 2 kg will be T by 10 for T less than 10 seconds. And then it becomes 1 for T greater than 10. Acceleration of 3 kg will be T by 10 for T less than 10. And then they will go together with T by 8 minus 1 by 4. This is between 70 by 3 and 10. Equalities are there because there is no mu k. And then this guy became constant 8 by 3. Then acceleration of 5 kg T by 10 for T less than 10. T by 8 minus by 4. T by 5 minus 2. Luckily, you'll always get straight lines only. As long as you give the time as t. If that is t squared, you're dead. Then you'll start getting parabolas. There. This is your final answer, acceleration in terms of time. Now, if I plot the graph, a t graph, first 10 seconds, this is your 2 kg. This is theta 1. This is your 3 kg. 3 kg becomes constant at 70 by 3. This is your 5 kg. You can clearly see the slope. Tan theta 1 is 1 by 10. Tan theta 2 is 1 by 8. Tan theta 3 is 1 by 5. The slope bumps up every time. Check. So 3 kg, 3 block problem, this is the biggest headache. You start with an assumption both are going together. Then you find the condition when 2 kg and 3 kg slip, that is 10 seconds here. Then find the condition when 3 kg, 5 kg slip, that is 20 seconds. Whoever is smaller, that is right. I hope everyone is getting why that is the case. Because you derived both of them, assuming the other one is not slipping. So whoever slips first, that is the main slipping, the other guy is wrong. So you cancel that and then you start the problem again, assume both are going together. Then again you calculate and then you know the process. Is this clear, everyone? Clear? Here we will not do mu s mu k, it will be more messed up. If you use mu s mu k, then you'll start getting discontinuities here. 3 blocks, if this much you can handle most of it. Devansh, clear with this?
Yes.
You should definitely try these things again on your own. Clear? Let's see one more. Now you guys try. Last one. I'll keep the number same. 2 kg, 3 kg, 5 kg. The ground is smooth. This is 0.2. This is 0.1. But you're applying force in the middle block. There, everything is same except that. Plot AT graph. Finish off. Got 3 minutes. Idea is the same. 3 blocks, that is the biggest headache. You have to check who's slipping first. Now you got the idea. If there's a 4-block problem, you do the same thing. 4-block problem becomes 3 blocks, 3 block becomes 2 block. You have to bring it end of the day to a 2-block problem. It is exhausting. Try. Today's class, you guys should definitely sit and resolve again. Why do you think I kept a separate session for 2 blocks? show you. Step 1, start with that. Assume all are going together. Acceleration A. So we get t is equal to 10. This thing looks like the starting part is the same, t by 10. Second part, now we don't know who is slipping. So let's draw the 2 kg FPD. This is F1, this is acceleration. F1 is 2a, this is less than equal to 0.1 into 22. T is less than 10 seconds. Yep, we got the same thing. 5 kg. This was the first part. 5 kg, there's only one friction, F2, and this is the acceleration. F2 is 5a less than equal to 0.2 into 50. 5t by 10 is less than equal to 10. Interesting. We got the same numbers that I was not expecting. Why did that happen? That is because it's a 5 kg block. It is just luck. This is gone, this is right. Then this part is done. So up to 10 seconds, everyone is going together. For t greater than 10 seconds, so far it is looking exactly same. F1, this will be F1 max. That is 2 newtons, and this is the acceleration of 2 kg. 1 meter per second square. Then assume 3 kg and 5 kg are going together. Now this friction F1 max is 2. Now here we have F is equal to T. T minus 2 is equal to 8. This is also same. Then take the 5 kg block. This would be F2 and acceleration. F2 is equal to 5a less than equal to 0.2 into 50. T by 8 minus 1 by 4 is less than equal to 2. Multiply 8. T minus 2 is less than equal to 16. This changed. Now the slipping is happening at 18 seconds. Previously it was 23.33, remember? So for t greater than 18, 3 kg and 5 kg slip. So the change started from here. So now we have F1 max 2 here. We also have F2 max here. This guy is how much? 10. So the acceleration of 3 kg is t minus 12 by 3. F2 max is 10. So acceleration of 5 kg is 2. So if you try to plot the graph, first the 2 kg will become constant like this. This is theta 1 and theta 1 is 1 by 10. This is 2 kg. Then 3 kg goes like this, and then the bump up. So till here, both the 2 kg, 3 kg will be like this only. How much is this? t by 8 minus 1 by 4. This is theta, so tan theta 2 is 1 by 8. And then this is your 5 kg. This guy became constant. This happened at 18 seconds. That became 2. Then the 8 kg, this 3 kg even bumped up more. This guy became t by 3 minus 12. This is a 3 kg. So it did change a bit. I think here the slope was 1 by 5, here it is 1 by 3. Problem changed after this thing. The slipping happened at 18 seconds. Have a look at the steps. Idea is the same.
Sir, why didn't we take the assumption that 3 and 5 go together in the previous problem?
I took, na?
Okay, sir.
दिया था मैंने.
Okay, sir.
T10 2 kg slips, so assume they're going to get. Is this clear, everyone? This is how you handle 3 block problems. 3 blocks technically not in the portion. Questions become tough because f is equal to t and they'll ask you graphs. Graphs is what makes this question really good. They said it as, only 2 blocks they mentioned. They didn't even say 3 blocks are not there, but they can ask. Clear this? With that, we are done with the chapter. So friction is done. So next class, when we catch up, we'll be starting off with circular motion. That is also an interesting chapter. So like I said, we finished plain dosa. Now we finished masala dosa. Now we are going to do onion masala dosa. We're just going to add one more thing. So circular motion will again kind of look like loss of motion and friction only. You're going to get everything that you have. But it'll be more fun. You'll have vectors, kinematics, NLM, friction, calculus, every damn thing. Okay, so with that, we'll wrap up for the day. So we have done almost 23 questions. So do make sure to go through this, right?